This is a walkSTEM in Busch Gardens, Tampa Bay in Florida. Busch Gardens is an amusement park with different forms of entertainment like thrill rides and carnival games. Our first stop is a milk carton toss in the carnival games section at Busch Gardens. The aim of the milk carton toss is to throw a ball at 3 milk jugs stacked on top of one another. Ideally, one would want to knock all 3 over in one throw. Where should someone aim to knock down the most bottles if the ones on the top are significantly heavier than the ones on the bottom? The center of mass is where all of the system's mass is concentrated. While thinking about your answer, keep in mind the equation for the x-coordinate of the center of mass. As you can see, it heavily relies on where the mass is distributed. To beat this game, it's useful to think about how redistributing an object's mass can affect how well it balances. How an object's mass is distributed can affect its center of mass, which is the average location of most of an object's mass. This basically means that the center of mass will shift to the object's heavier side if the mass isn't uniformly distributed. Since the center of mass moves higher if the bottles on the top have a higher mass, one would actually want to aim lower at the pyramid because the pyramid is unstable and it would take less force to knock down more bottles. Our second stop is the Grand Caravan Carousel in Busch Gardens. You will notice that the carousel rotates at a constant angular velocity, and every horse begins and ends in the same positions relative to its center. Given 2 horses in the same position relative to the center, but different lengths away from the center, which horse has a higher linear velocity? The one closer to the center of rotation or the one further? In thinking about your answer, remember that velocity is distance divided by time. Think about which values are the same and which are different for both horses. Since the horses on the outside and inside begin and end in the same positions relative to the center in the same amount of time, yet the outer horses on the carousel travel a greater distance than the inner horses, it is true that the linear velocity on the outer horses is greater than the linear velocity on the inner horses. Our next stop at Busch Gardens is a basketball carnival game. The aim of the game is to shoot the ball into the hoop, but you may notice that sometimes the ball collides with the backboard and bounces back towards the person who shot it. If you hit the backboard, why does the ball bounce off of it and come back to you rather than just dropping straight down? While solving this problem, keep in mind the momentum and impulse theorem. The change in the momentum is equal to the force times the change in the time. According to the momentum impulse theorem, if you impart an impulse onto a system, its momentum will change. Clearly, the momentum of the ball is changed by the collision with the wall. Since the direction of the ball's velocity is completely reversed, it follows that the wall must exert a force on the ball, since force is the rate of change of momentum, so the ball will return. Our last stop in Busch Gardens is Stanley Falls Flume. This amusement ride consists of a water flume and artificial hollow logs or boats. Passengers sit in the logs, which are propelled along the flume by the flow of water, and go down a large drop towards the end. How does the water on the slide affect the speed of the ride? While doing this problem, remember that friction is working against the gravitational pull. Friction is equal to the coefficient of kinetic friction times the normal force, which is mass times gravity. Also remember that the water is reducing the contact area between the 2 surfaces. Water, under certain circumstances, may come between 2 surfaces and act as a barrier to reduce the amount of contact area between these 2 surfaces, and hence reducing the friction between them. Friction acts in the opposite direction of the motion, so by reducing the force acting in the opposite direction of the motion, you can increase the speed of the log. Thanks for coming along the walkSTEM at Busch Gardens.